So, we are discussing about solving optimization problem. In the last few lectures, we have learned about how to solve single objective optimization problem. In the last lecture, we were discussing about solving multi objective optimization problem, which are more applicable in our real life applications. Today, we will continue the same discussion. Today, mainly we will discuss about some properties, some characteristics which is very much essential to solve multi objective optimization problem. And after we learn that different characteristics, then we will discuss the different approaches to solve multi objective optimization problem. Now, so we have planned our discussion in subsequent lectures like first how the solutions with multiple objectives are characterized, and then the solution possesses some important concept. It is called the concept of domination. We will discuss it, and then we will try to learn about the relation, that is the properties that a dominance relation holds, and finally, we learn about Pareto optimization techniques or is a Pareto optimization concept. So, all these things we will learn one by one. So, let us first start with solutions with multiple objectives and how they can be characterized. Now, let us consider for our discussion, say that there are m number of objective functions, and these objective functions are conflicting objectives. Conflicting objective means if you try to minimize both say f 1 and f 2, then when you try to minimize f 1, f 2 not necessarily to be minimized or vice versa. That means, there is a trade off. If you want to minimize both, then there may not be any solution. So, we have to have some conflicting objectives. If it is there, then essentially there exist many optimum solution. Now, if it is possible to exist one different solution which is basically satisfying both the objectives simultaneously, then we can say that such a solution is called the ideal solution. So, solution which has the ideal solution also called solution, ideal solution, and then the objective functions which basically holds good like this, it is called the ideal objective vector. Now, so here the same thing is discussed in a more precise or more formal method, formal way. So, say here basically for the simplicity we assume that all the functions, all the objectives are to be minimized. So, it is basically it is a generalization. It can be, there are maybe some objective function to be minimized, some to be optimized, but we know with the virtue of principle of duality problem, all objective function can be converted to only one type. So, let us consider there are m number of total objective functions, and out of which each objective function are to be minimized, and then they are basically subject to x s, where s denotes the search space. That means, we have to find a solution x in the search space S, which basically satisfy all the criteria simultaneously. That means, here if f star is the optimum function, then it is optimum with respect to all, that means f 1, f 2 and f m. Then this solution is called the ideal solutions, and all the objective vectors, these all the objective vectors are called ideal objective vectors. Now, the same thing can be discussed with a visual description and illustration, right. Now, here suppose f 1 and f 2 are the two objective function, and we assume that f 1 is to be minimized and f 2 is also to be minimized for simplicity. Now, so in this is the search space this is the search space for the entire what is called the searching of towards the optimum values. Now, out of this search space we can see there is one solution, this one, which is basically satisfying all the objective functions simultaneously. So, if this is the solution, then it is f1 is minimum and f2 is minimum. Now, if we consider any other solution, we can say that this is not the solution which simultaneously satisfying this one. For example, if it is minimum f1 is also not minimum, then f2 is also not minimum. So, like this. So, the solution point which basically signifies this one, it is basically corresponding to the ideal objective solution, and if there is an objective function which exists there, then it is called the ideal objective vector. So, this is the concept, it is there. Now, so this solution, as we have discussed about, it is called the ideal objective solution. Now, in this figure, if we see it again, we can see that this is the one solution, this is the one solution. This solution may be minimum with respect to f2, but this solution is not minimum with respect to f1. Similarly, this solution is minimum with respect to f1, but not with respect to f2. However, if we can find one solution like this, which is obviously not exist here, then we can say this is the one solution which is minimum with respect to both f1 and f2. Now, so this is the case if we have, then say suppose this is the one search space, that means we find many solutions in this region, then definitely this is the one solution, this is their trade off solution. That means, if it is good with respect to f2, but not good with respect to f1 and vice versa. Now, if there is any other solution which is very close to this ideal solution, then we can say this solution is more preferable than any other solution in the search space. So, while we are searching, if we find one solution which is not necessarily an ideal solution, but very close to the ideal solution, right, then this solution can be considered as a solution of our objectives. So, this is a desirable solution. So, a good solution vector should be as close as to ideal solution vector. So, this is the interpretation that we can have from this concept ideal solution, ideal objective solution. So, here now we can generalize little bit precise about, say suppose there is a multi objective optimization functions with two objectives f1 and f2, where suppose both are to be minimized, Now, so if there is a solution, we say that this solution is f1 star f2 star, then both f1 and f2 are minimum at x star, that is the solution space belongs to the search space. Okay. So, in general the ideal objective vector. So, this is basically the ideal objective vector. So, z star we can say it is an objective vector which is ideal, right. In fact, the ideal objective vector corresponding to a non-existent solution, that is why we call it as an ideal, because many multi-objective optimization problem are with conflicting objective. It is very rare, it is in fact impossible to see one objective function which is one objective vector which is minimum with respect to both the objectives. And if there exists an ideal solution, then the objectives are non-conflicting with each other, and then minimum solution to any objective function would be any optimum solution to the problem. So, this is the concept of ideal. So, ideal objective vector is non-existing one solution we can say. Now, okay, fine. Now, so we have learned that ideal objective solution, solution is usually non-existing, but it is useful in the sense that any solution closer to the ideal objective vectors are preferable. So, this is the usefulness of this concept of ideal objective vector. Now, we will discuss about another solution. Such a solution is called the Utopian solution. Utopian means it is a fictitious, it is never possible like an ideal also, but it is in another extent. Now, let us define how the Utopian solution can be. A Utopian objective vector, so we denote it as J star star, has each of its component marginally smaller than that of the ideal objective vector. So, if Z1 star is the ideal objective vector, then J star will be far better than ideal objective vector. So, it is basically this with epsilon I greater than 0. So, that means Z1 double star is far better than Z1 star. Then such a solution is called the Utopian solution, and then solution vector, if it is possible, then it is also called the Utopian objective vector. Now, let us illustrate the concept with an illustration. Now, here this figure is planned to illustrate the concept of Utopian objective vector. Now, this is the search space, and we have learned that this is the one solution which is called the ideal solution, and then Utopian solution is far better than the ideal solution, means this is the one solution is an Utopian solution, and the vector for which satisfy this solution is called the Utopian objective vector. Now, so we have learned about the ideal solutions and thereby the Utopian objective vector. Now, as we have learned about it, like ideal solution is non-existing for conflicting objectives, similarly the Utopian solution is also a non-existing solution when the objectives are conflicting of type. So, this is the two solutions type, one ideal solution and Utopian solutions. Now, we learn about another solution, it is called the Nadir solution. Now, let us see what exactly the Nadir solution is. We can explain this concept by means of a example. Say this is the solution the search space, all solutions possible, and both F1 and F2 are to be minimized for the sake of generality, and then so this is basically in our case it is the ideal solution, and then there is one Z star solution which is basically minimum with respect to F1. Similarly, there is another solution Z1 star which is minimum with respect to F2. Now, so for this Z2 star we can see the F1 is maximum, and for the Z1 star we can see for the Z1 star F1 is maximum value, and for the Z2 star also F1 is maximum. So, this is the one solution if we say which is on the boundary or basically close to the solution, then there is an extreme solution. Such an extreme solution is called the Nadir solution. Now, so Nadir solution is like this. So, it is basically the extreme values with respect to the optimization objectives, and then there is another solution, suppose this one, and this is another solution is this one. These are the basically again another extreme solution in the solution space. Now, extreme solution with respect to we can say it is F2, and this is an extreme solution with respect to F1, and then there is another solution which is like this, having this satisfaction. Then this solution is just like a Utopian solution in case of ideal objective. It is basically then another Utopian solution with respect to Z Nadir. Now, so this basically gives an idea about how the scope or range of the solutions may be there. Now, so this is the idea about the Nadir objective vector, and so in a simple word, the Nadir objective solutions is the upper bound with respect to the set of all optimum solutions. We will term all these solution as the Pareto optimum solution. We will term them as the Pareto optimal solution. So, it is basically the upper bound in that sense. Now, so having this is the concept, we will just see exactly what is the usefulness of these solutions. Okay, we have learned about the usefulness of ideal objective vector. Now, similarly, there is an application of the Nadir objective solution for a given this one. So, that can be explained by this form. So, this solution, the Nadir objective solution, usually used to scale the objective vectors. The scaling of objective vectors we have learned while we are discussing about scaling in case of single objective genetic algorithm. Now, so this is the one idea here. If Z I star is the ideal objective solution and f1 is the any objective vector and the Z I Nadir is corresponding to the Nadir objective solution, then the scaled objective function can be denoted by this and it satisfies this formula. So, this is the one what is called the idea where the ideal objective solution and the Nadir solution is used. So, it is basically used to scaling the objective vectors. So, we have learned about the different solutions that may have there in with respect to two objective functions we have discussed, but that idea can be extended with respect to multiple objective vectors as well as. Now, we will discuss about another important concept, it is called the concept of domination. Now, concept of domination, as I told you, so there are some objective functions which are conflicting. Okay. Then let us suppose the m. So, there are m number of objective functions and there exist any two solutions, say x I and x j are any two solutions in the search space. Now, we can define an symbol, it is basically an operator between two solutions x I and x j to denote that x I dominates x j, to denote that solution x I is better than the solution x j for a particular objective on a particular objective with respect to one particular objective. Similarly, if x I dominates x j or x j dominates x I, this kind of symbol can be used. Now, here our objective or the discussion that we are going to discuss about that, if two solutions are given to you, then how you can decide that the one solution dominates other solution or no one dominate each other. So, dominate in the sense that one solution is better than the other solution. So, this concept is called the concept of domination and it basically okay. So, there is a precise definition for the domination. Suppose two solutions x I and x j are there, then we can say that solution x I dominates another solution x j if they satisfy two conditions. So, both the conditions are to be satisfied, then only we can say that x I dominates the solution x j. In other words, in a simple words, x I is a better solution than x j. Now, so the condition the first condition is that x I is no worse than x j in all objective. That means, there are objective function for all objective function k, where k equals to 1 to capital M, and then that solution does not dominate any other solution. So, it is basically the first condition. That means, okay, we will illustrate with an example anyway. So, this is very important, what is important one statement that x y is no worse than x j in all objectives, So, these are the things to be noted. And the second condition is that xi is strictly better than, that means it is better than always in at least one objective. So, it is basically again this point to be noted is strictly better than and at least one objectives. So, if these two conditions are satisfied between xi and xj, then we can say that xi is xi dominates the solution xj. Now, let us say let us see the example, so that you can understand about it. Now, in this example f1 and f2 are the two objectives, and so these are the solution space. This is also another solution which is not in the search space or whatever it is there. Now, out of this solution this and this, we have to check that which solution dominates which other solutions. Then definitely our objective is to select those solution which dominates all other solution. If there exists one solution which dominates all other solution, that will be the our desirable solution. Now, let us see what are the different situation may occur, so that we can understand which solution dominates other, or how the dominant property is can be this one can be satisfied. Now, this is the diagram that I have planned it, so that you can understand it, and I am discussing about with respect to the different what is called the different objectives type. For example, here this is minimize f1, this is minimize f2, this is maximize f1, it is maximize f2, and like this. Now, anyway, so if we see in these slides, we can understand that this is the one solution and this is the one solution, right. Now, this solution and this solution, if we see, so this solution, so far the f1 is concerned, right, f1 is concerned, it is worst or it is not good as the this solution f2 is concerned, because this solution f2 has the better with respect to f1. On the other hand, this solution is also good with respect to f2, but not with respect to f1. However, this is the one solution which is good with respect to both this solution as well as this solution. So, we can say that this is the one solution which dominates this solution. On the other hand, this solution or this solution x, so if this is x1 and this is x2, then we can say that neither x1 dominates x2 or x2 dominates x1, because the condition 1 and condition 2 are not satisfied for this solution x1 and x2. However, condition 1 and condition 2, both the conditions are satisfied for this solution. Now, so in this context, what we can say is that this solution dominates these are the solution, whereas x1 and x2 does not dominate each other. Now, similarly, all the solution which lies on this region, they are basically non-dominating, no one dominates other, but any other solution or any other solution here also we can say these solutions is better than this solution in some respect. So, we can say that all solutions dominates all other solutions here. So, this concept can be understood from if we verify the two properties. Similarly, in this example, the same as this one, but is a maximize f1 and f2, we can extend the same idea for these two solutions, and then we can check that these are the solutions which do not dominate no one solution, and this is the one solution which which basically is dominates any solution within this one. So, this is basically a dominating solution, and these are the non-dominating solution. Okay, fine. So, the same thing can be extended for the other minimize and this maximize, and this is maximize and this minimize, and these are the solution is basically these are the solution we can these are the solution is basically dominates any other solutions here, but all the solutions which lies on this region are non-dominating, the same thing it is there. Now, so this is the concept of domination. If you want to understand more precisely about this concept, then then I can plan one example. Okay, so let us illustrate the concept of domination, because it is very important, and then it is okay, we have to okay, we will explain 3 cases, so that we can understand the concept it is there. So, case 1, and suppose f1, f2 and f3 are the 3 solutions, are the 3 objective vectors, and there are 2 solution 1 and solution 2. Now, say solution 1 is suppose okay, both are to all these objective vectors are to be minimized, and say solution 1 has the result say 2, 3 and 5, and then solution 2 has the result 4, 4, 6. Now, in this case, okay, so f1, f2 and f3 are all to be minimized. Now, if we consider so then this solution solution 1 and solution 2, if we compare, then solution 1 condition, so condition 1 so far this is it is no worse than any other objective function. So, the condition 1 is satisfied for the solution 1, and then also with respect to at least one, this solution has the satisfied. So, that means, in this case both 4, 4, 6 and here 2, 3, 5, with respect to all, this solution satisfies this one. Then we can say that this solution 1 dominates the solution 2. Now, another example, so it is case 2, same thing earlier. So, again f1 and f2 and f3 are the 3 objectives which are to be minimized, and there are 2 solutions, solution 1 and suppose solution 1 is 2, 3, 4 and the solution 2 is 2, 3 and 6. Now, in this case, so solution 1 is no worse than any solution there in solution 2, and it solution 2 and 3 and solution for f1 with respect to f1 and f2 both the solutions are same, but at least with respect to f3 this solution is better than this solution. Then we can say again here solution 1 and solution 2, solution 1 dominates solution 2. Now, let us see another case 3. Again we will consider f1 and f2 and f3 both are to be minimized, and there are 2 solutions, solution 1 and solution 2, and let the solution 1, 2, 3, 5 and 1, 4, 6 this kind of solutions are there. Now, here we can see so solution 2 is better with respect to f1, however, it is worse with respect to both f2 and f3. So, this means that neither solution 1 and solution 2 dominates, that means solution 1 neither dominates solution 2 or solution 2 does not dominate solution 1. So, this is the example that can be helpful to understand the concept of dominance there. Now, so we have learned about the dominant the concept of domination. Sometimes many language that can be used to represent or notation also. So, here if x I dominates the solution x j, then we can write this kind of symbol also use for brevity, and also it can be termed as x I is dominated, x j is dominated by x 1, or x I is non dominated by x j, or x I is non inferior or to x j. These kind of solutions are there anyway. So, meaning whatever the way we can express it, the concept is like this one. Now, we can illustrate the same concept, 2 more slides are there as you have discussed already. You can verify yourself that here x 1 and x 2, x 1 dominates x 2. Now, similarly x 1 and x 3 if we consider, then x 1 dominates x 3, but if we consider x 2 and x 3, then neither dominates this one. So, here we consider f 1 are to be minimized and f 2 are to be minimized, that you can verify yourself. So, this is the thing that we have written here, and these are the things we can verify yourself. Now, second illustration here, just okay, this is minimize f1 and maximize f2. So, here also the okay. So, it is basically minimize and maximize, that means the objective that solution, the solution it is basically it is like this or whatever it is there. So, if we consider x1 and x2, because it is a minimize and is maximize, the solution region will be look like this one. So, all the solution which is on this region, they are basically non-dominating each other. However, any solution if we consider this one, it is preferable and optimize this one. So, this way we can verify that x1 and x2, x1 dominates x2 in this case, and then x1 also dominate x3, right, and so so but x1 and if we consider x2 and x3, they are not dominating each other. So, that you can verify and then understand about it. And similarly, this is another case where the f1 is maximized and f2 is minimized. So, the idea it is that it is like this. So, you can say that is there. So, any solution not dominates this one, but here if we consider this solution, right, or these are the solutions which dominates all other solutions. So, it is like this. So, all solutions dominates any solution which is on this range, on this line, or so similarly. So, we can say that if this is the search space, then all these solutions are dominated by all the solutions, but here no solution dominated by this one, and then the concept is like this. Anyway, so it require little bit thorough checking, and then you can understand that which solutions dominates which other solutions. Okay, so this okay, this is the concept of domination, and then we will discuss about important properties this domination solution holds good, that will be covered in the next lecture. Thank you.